Welcome to Hydropower. Today we will be discussing about the planning and classification of hydropower. So first let's start with the classification of hydropower. So classification of hydropower is 1. Based on head. 2. Based on installed capacity. 3. Based on storage. 4. Based on construction feature. 5. Based on mode of operation. 1. Based on head. Very high head hydropower, head greater than 350 meters. Pelton turbines are used. High head hydropower, head greater than 150 meters and less than 350 meters. Both Pelton as well as Francis are used, but for higher specific speed Francis is more economical and compact. Medium head hydropower, head greater than 60 meters and less than 150 meters. Francis turbines are generally accepted. Low head hydropower, head greater than 30 meters and less than 60 meters. Both Kaplan and Francis turbines can be used. Very low head hydropower, head less than 30 meters. Axial flow turbines likely Kaplan, tube, bulbs etc. are accepted. 2. Based on installed capacity. In the context of Nepal, based on installed capacity hydropower are classified as 1 micro hydropower project up to 100 kW, 2 mini hydropower project greater than 100 kW less than 1000 kW, 3 small hydropower project greater than 1 MW less than 25 MW, 4 medium hydropower project greater than 25 MW less than 100 MW, 5 large hydropower project greater than 100 MW. 3. Based on storage. RIR plants. Run-of-river hydropower plants do not have significant storage capacity. Instead, they rely on the natural flow of rivers or streams to generate electricity. These plants divert a portion of the flowing water into a channel or penstock, which passes through turbines to generate power. Run-of-river plants do not impound water in reservoirs and thus do not store large amounts of water. Example: Lower Huacola, Mid-Salucola. PIR plants. Hydropower facility that is designed to operate during peak demand periods, typically when there is a high demand for electricity. These plants are optimized to generate electricity when the demand for power is at its highest, which often corresponds to periods of peak electricity usage during the day. PIR hydropower plants typically include storage features to store water during periods of low demand and release it during peak demand periods. This storage capacity allows them to generate power even during periods of low water flow. Example: Middle Marsiangdi and Marsiangdi. Storage plants. A dam is constructed to create large storage to store water from rainy season to dry season. It requires high initial investment. Example: Kulakani and 2. 4. Based on construction feature. Impoundment hydropower. Impoundment hydropower plants are characterized by the construction of a dam or reservoir. Impoundment hydropower plants can be further categorized based on dam types, such as concrete gravity dams, embankment dams, or arch dams. Diversion hydropower, also known as run-of-river hydropower plants, which divert a portion of the flowing water from a river to a powerhouse through a canal or penstock. These plants do not require a large dam or reservoir but utilize the natural flow of the river or stream to generate electricity. Offshore hydropower. These plants are constructed in bodies of water such as oceans, seas, or large lakes. These plants utilize tidal or ocean current energy to generate electricity. It also can involve the installation of turbines or devices that capture the kinetic energy from water currents. 4. Based on construction feature. Underground hydropower. Underground hydropower plants are constructed entirely or partially underground. These plants are typically located in mountainous regions with suitable geological conditions. These plants can utilize a natural flow of water from underground sources or divert water through tunnels to generate electricity. Small-scale hydropower refer to smaller installations designed for decentralized power generation. These plants are often constructed on a smaller scale, such as micro-mini hydropower systems, or small run-of-river installations. Small-scale hydropower plants can be designed to meet the energy needs of individual households, communities, or specific applications. 5. Based on mode of operation. Isolated plant, ability to function independently and autonomously, disconnected from the main power grid. The hydropower plant generates electricity for a localized or isolated area without being interconnected with a larger transmission and distribution network. Is commonly seen in remote or off-grid areas where there is no access to a centralized power grid. Base-load hydropower plant. It operates continuously at a constant rate, providing a steady and consistent supply of electricity. These are designed to meet the baseline or minimum level of electricity demand that persists throughout the day. Peaking hydropower plant. These are designed to operate during periods of peak electricity demand when the demand for power is at its highest. These plants are optimized for quick startup and ramp-up capabilities, allowing them to rapidly respond to increased demand and provide additional power to the grid. Base load and peaking hydropower plant are also called as grid interconnected plants. See you in next video.